Welcome tonight. Thank you for coming, and thank you to Jody and Megan for attending on Zoom. Those are our clients. We are Indoor Systems, and we are giving our final pitch tonight. So just a quick introduction. So meeting the team, my name is Reed Bond, and I'm a mechanical engineering student.
So what's the problem? So senior living in senior home have a problem to open the door, unit door, because it's had the auto closers attaching to it. Auto closers is a requirement to all commercial building, and there's a solution need to have device which is like reduce the force to open the door.
So on to our design process here. So first we identified the problem. Dylan was working in another class with senior homes, and he was talking to some of the staff, and he found that a big problem was that seniors have trouble opening their unit apartment doors. So we identified that problem. We researched potential ways we could solve this problem. And then we communicated with clients about like potential solutions and what they wanted to see incorporated into the design. We then integrated their feedback, we designed the prototype, and we built the prototype, and we will give a demonstration of what the prototype looks like and what it does at the end here.
Okay, so why retrofit? Our solution and all associated door components must be fire certified and conform to all the applicable standards as seen there. We also met with Brian Conway, who's a fire marshal with Saskatoon Fire Department, to gain approval for design and other considerations. So the ability to retrofit a design makes it simple, and it can apply to more than one existing setup. This retrofit solution saves the client money on installation costs and potential replacement of other door components. So moving on to the mechanical design, the considerations addressed. Again, the retrofit solution, we are assuming the existing doors are already to fire code. We used a 1:4 gear ratio. It's made out of steel construction. We maximize the arm length, so we increase the torque. And as well, the arm pivots for increased mobility. The why, it adds mechanical strength for safety, durability, and reliability.
And then over on the electrical side, sort of joining together the digital logic that powers the device and the mechanism that opens the door, we elected to go with a stepper motor driven system. This is for a couple of reasons. One, because the position is always tracked when you're using a stepper motor, so we know where the door is at all points in its opening sequence. And it's also very power efficient for the amount of torque that you can get out of it. In addition to that, we've integrated a MOSFET power switch, which essentially just means that the door is not receiving any power unless we want it to be. So there's not any leaking through when it's off or anything like that, and that should give the client some additional power savings.
On the computer end, we use the microcontroller as the brain of the logic system, simply because our design was not complex enough to require something like a Raspberry Pi, which would be like a mini computer. We used an infrared sensor for the safety, and currently the door is button activated, as well as another switch to simulate like the fire integration, because the door in a real life scenario will need fire safety integrated in it. For the software, we use the FreeRTOS for scheduling. And why did we use these components? We're aiming for something that was cheap, reliable, and performed well. And in terms of software, we needed something that could easily schedule tasks and scale it rather than using, for example, while loops, as some of you may know. Yeah. So the solution that you will see later today and in the video, I'm not sure if we're showing it. I think so. Yeah, it has all these features that we mentioned earlier, which includes the motor, the fire alarm integration, and accessible activation.
So here's our demo. The video. Okay. So we're gonna run into like 4 different modes. First of all, it's like we're running normal with the activation button. Just open the door. So the door gonna open it, and it's in the opening state. And next go to like holding state, which is gonna hold the door for about 6 seconds. Yes, the door is right now in holding positions, and the door gonna hold for 6 seconds. And the doors, we're gonna shut down the motor, and the door closes itself. The second mode, we're gonna have Keegan gonna assist me with this. So we're gonna open the door, and during the operations, Keegan gonna just interfere and walk by. And if he's here, the door automatically close for safety issue. And then when he gone, the sensor gonna detect this, like he's not there anymore, and then it continue to operate. Yeah, here we go. And then it's go to close positions, wait for another 6 seconds, and it's real close. Yeah, the third mode, we're gonna just like operate normal, but during the holding position, if the sensor detect a person just walk in and out, and they need more time to access to the door gonna continue to hold it. The timer gonna reset it until that person is no longer there, and therefore it's gonna release the auto closing device. And there we go. I'm gonna walk into the door and try to like stay there for a little bit, and the sensor is detected, and at this time the door gonna continue to hold it. And then I leave the door, and then it require another 6 seconds because like nobody there now. So the final mode is like we cooperate with the fire alarm. Represents like the button, like the alarm button. If the alarm signal is turned on, is the system gonna automatically shut down, and then the motor is shut down, and then the door gonna just closes itself using the auto closing device. Okay, and I'm gonna push the button. It's not gonna hold it anymore, and then the door is closing. Yeah.